Dear students, welcome to Samveda E-class learning program, 8th class mathematics, unit 5, squares and square roots. Already we have discussed some aspects of this unit in session 1. Before we proceed further, let us have a recap of what we learnt in session 1. We learnt about perfect square numbers, digit in units place of a perfect square number, triangular numbers, number of integers between two consecutive perfect square numbers, sum of natural numbers and perfect square numbers, sum of odd natural numbers and perfect square numbers, and how to find the perfect square numbers for a given natural number. So, before we proceed further, we have one more important aspect related to perfect square numbers, that is Pythagorean triplets. As the name suggests, it is a triplet of 3 numbers which satisfy certain conditions, and let us see what are those conditions. The condition is 3 natural numbers are said to be Pythagorean triplets if square of the largest among them is equal to the sum of the squares of the other two. For example, consider the natural numbers 3, 4 and 5. Here you can see square of 3 plus square of 4 is equal to 9 plus 16, which is again equals to 25, and we know that 25 is nothing but it is square of 5. That means 5 square is equals to 3 square plus 4 square. So, we can say that 3, 4, 5 are Pythagorean triplets. Now, we shall have some more examples of Pythagorean triplets. Example 1, 5, 12 and 13. Another example is 7, 24 and 25, 20, 21 and 29, etc. You can find many more Pythagorean triplets, but you might be wondering, is there any easy way to find the Pythagorean triplets? Yes, of course. You consider any natural number greater than 1. That means, if m is a natural number greater than 1, then 2m, m square minus 1 and m square plus 1 forms a Pythagorean triplet. That means, in place of m, if we go on substituting 2, 3, 4 and so on natural numbers, we can generate infinitely many Pythagorean triplets. For example, putting m equals to 2, we get m square minus 1 is nothing but 2 square minus 1 equals to 3, 2m equals to 2 into 2, which is equals to 4, and m square plus 1, which is nothing but 2 square plus 1, which is 5. Now, you can see 3, 4 and 5, and already we know that 3, 4 and 5 form a Pythagorean triplet. Now, we have done so many operations on numbers, mainly addition, subtraction, multiplication and division, and we know that inverse of addition is subtraction, inverse of multiplication is division, inverse of square is what? Yes, it is a square root. What does it mean? Let us have an example. Already we have done this activity while describing the perfect square number. Yes, this you have already used to count the number of unit squares in the chessboard. Now, the question is reverse. Here we know the number of unit squares in this chessboard, and the question is how many unit squares are there in each row or each column. In other words, the question is to find which number is multiplied by itself to get 64. This can be done. 64 equals to which number into the same number? That question mark we have to find. What is the number to be placed in place of that question mark? We know that square of 8 is 64, and if we ask the same question in reverse order, 64 is square of 8, then what is 8 to 64? 8 square is 64, therefore, square root of 64 is 8. We write this symbolically, the symbol is put over 64. Square root of 64 equals to 8, and the symbol we are using here is a symbol for square root. So, whenever we use this symbol, we have to understand that this is a symbol of square root. Again, equal integers may be positive or negative. When we are finding the square root of a perfect square number, we get two square roots, one is positive and another one is negative. But as far as this chapter is concerned, we will discuss only about the positive square root of a perfect square number. Now, how to find the square root of a perfect square number? Methods of finding the square root. Mainly, we have three methods. Among them, the first one is by repeated subtraction, second one is by prime factorization, and the third one is by long division method. So, first of the three methods is finding the square root by repeated subtraction. As we already discussed, any perfect square number can be expressed as sum of first n odd positive integers or odd natural numbers. Let us see the example. Here we are adding the first 6 odd natural numbers, that is 1 plus 3 plus 5 plus 7 plus 9 plus 11, and we know that it is square of 6, which is nothing but 36. So, as I said, the reverse process of square is square root. Now, we got 36 by adding the first 6 odd natural numbers. So, if we go on subtracting these first 6 odd natural numbers from 36, we get its square root. Let us see how this will work. So, here step 1, we will subtract the first odd natural number from 36 to get 35. Now, from 35, we will subtract the second odd natural number, which is 32. Then from 32, the third odd natural number 5 is subtracted to get 27, and in step 4, we subtract 7 from 27, which is the next to 5, to get 20. From this 20, the next odd number 9 is subtracted to get 11, and in step 6, we subtract 11 from 11 to get 0. This process is continued till we get 0. Here we got 0 in 6 steps, therefore, we can say that square root of 36 is 6. To get a more clear idea of this process, let us have one more example. Find the square root of 64 by repeated subtraction. As we did in case of 36, from 64, first we will subtract 1 to get 63, then subtract 3 to get 60, subtract 5 to get 55, 7 to get 48, 9 to get 39, 11 to get 28, 13 to get 15, and 15 to get 0. So, here we got 0 in the 8th step. Therefore, we can say that square root of 64, you can see square root of 64 is 8. So, let us go for the second method, which is called by prime factorization method. So, before we go to this method, we should understand two things. One is what is meant by prime number. You are already familiar with prime numbers, and another thing you have to know about is factorization, that also you know very well. So, the combination of these two we have to understand. First, let us recall prime number. A natural number greater than 1 is said to be a prime number. See the condition. For a number to be prime, it should be greater than 1 and it should be natural number. So, a natural number greater than 1 is said to be prime number if it has exactly two distinct factors. The factors should be 2, they should be exact in the sense they should not be more than 2 factors or less than 2 factors. If at all there are 2 factors, those 2 factors must be distinct, and the numbers which follow this definition are 2, 3, 5, 7, 11, 13, 17, 19, 20, 29 and so on. We can list infinitely many prime numbers. So, then factorization. Factorization is nothing but expressing a given number as the product of two or more than two numbers. So, it is a factorization. Suppose if a number is factorized in such a way that all the factors are prime numbers only, then that factorization is called prime factorization. So, expressing a natural number as a product of only prime numbers is called a prime factorization. So, to better understand the meaning of prime factorization, let us have an example of prime factorization of 60. So, we know that 60 first begin with the smallest prime number, that is 2. When 60 is divided by 2, we will get the quotient 30. Next, again 30 can also be divided by 2 because it is an even number, again divided by 2 to get the quotient 15. But this time 15 is not even, that means it cannot be divided by 2. So, go to the next prime number, which is 3. So, when we divide 15 by 3, we get the quotient 5. Now, as you know, 5 cannot be divided by 3, therefore, we will move to the next prime number, which is 5. When 5 is divided by 5, we get 1. So, we will continue this process till we get 1. So, once we get 1, we can express the 60 as the product of 2 into 2 into 3 into 5. You can notice 60 is factorized here and all the factors, that is 2, 2, 3 and 5, they are all prime numbers. Remember, 60 can also be written as 5 into 12. It is also factorization, but 5 is prime number, 12 is not prime number. Therefore, that factorization is not called a prime factorization. When factorizing a number, if each and every factor is a prime number, factorization is called prime factorization. So, following this, we can find the square root of a perfect square number by prime factorization method. As we did in the case of 60, let us express 900 as the product of only prime numbers. That means, factorize 900 as the product of prime numbers. So, first divide by 2 to get 450, then again we can divide because 450 is even, we get 225. Now, 225 is odd, which cannot be divided by 2. So, let us move to 3, sum of the digits is 9, therefore, we can divide 225 by 3. So, to get 75, again sum of the digits is 12, which can again be divided by 3. So, divide by 3 to get 25. Now, 25 cannot be divided by 3. So, move to the next prime number, which is 5 to get the quotient 5, and finally, divide 5 by 5 to get the quotient 1. Now, we can express 900 as the product of 2 into 2 into 3 into 3 into 5 into 5. Now, let us express them as the squares. Since 2 is repeated 2 times, 3 also 2 times, 5 also 2 times, we can write them as 2 square into 3 square into 5 square. Now, by using the law of indices, we can write it as 2 into 3 into 5 whole square, which is written as 30 whole square. That means, 900 is the square of 30. So, when we move in the reverse order, we can say that square root of 900 is 30. So, this is symbolically written as square root of 900 is 30. Let us go to the third method of finding the square root of a perfect square number. So far, we have discussed two methods. Now, this is the third method, by long division method. Remember, this method is quite different from our usual division of numbers. So, let us see what is the difference between our usual division and this long division of finding the square root of a perfect square number. Let us consider these perfect squares. In first group we have single digit perfect square numbers or one digit perfect square numbers. In second list we have 2 digits perfect square numbers, and in third list we have 3 digit, and in fourth list we have 4 digit perfect square numbers. And look at the smallest one digit perfect square number and the largest one digit perfect square number. In the same way, smallest 2 digit and largest 2 digit perfect square numbers, smallest 3 digit and greatest 3 digit perfect square numbers, and smallest 4 digit and the largest 4 digit perfect square numbers. These we have to keep in mind. Again we will see a list of square numbers and their square roots. Square root of 9 is 3, square root of 16 is 4, 81 is 9, 100 is 10, 961, 31, square root of 1024 is 32. So, we have started from the smallest one digit perfect square and we are having the largest 4 digit perfect square number. Now, look at the smallest one digit perfect square number and the largest 2 digit perfect square number. Their square roots are having only single digit, whereas the smallest 2 digit perfect square number and the largest 4 digit perfect square numbers, they have the square roots of 2 digit numbers. What does it mean? It means a square number, consider 100, we can group it into two groups. Starting from the units place, we count 2 digits together and make the one group from units to 10. Then we go to the 100th place and there is one more group. So, we have two groups in 100. Therefore, square root of 100 must have 2 digits, and we know that square root of 100 is 10. Similarly, consider the square number 9801, it has 4 digit, and as we did in case of 100, we will begin with the units digit and go to the 10th digit, we will make a one group, and next hundreds and 1000 digits together will make one group. So, it has two groups, therefore, its square root should also be a 2 digit number, and we know that square root of 9801 is 99, which is a 2 digit number. So, keeping all these points in view, we will find the square root of 476 by long division method. So, first thing, as we did 576, we have to group together. Start with the units digit, that is 6, tens digit, that is 7. Together they will form the first group, then go to the hundreds place, they will form, it will form another group. So, 576 has square root which is having 2 digits. So, what are those 2 digits? Let us take the first group, that is 5, that is 100th place number is 5. Now, 5 is greater than the perfect square 4 and it is smaller than or lesser than the perfect square 9. So, 5 lies between two consecutive perfect squares 4 and 9. Among these, we have to consider the smaller perfect square number, that is 4, and we know that 4 is the square of 2. Then we should take 2 and multiply with it 2 to get 4 and subtract 4 from the first group, that is 5. Then when we subtract 4 from 5, we get 1, and in usual division we will just write the next one digit only, but in this method we will write the next group, not the digit. So, next group is 76. Now, we get the remainder 176. One more thing that is different from the usual division is that in the next step we will add that 2 to this 2 to get 4, and after 4 we have to write a digit in this box, and the condition is that the same digit we have to write here also. to get 176. Now, we know that there are 10 digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Should we check for each and every digit so that we get 176? No, it is not necessary, because in our previous session we have seen that if a perfect square number ends with 6, the number whose perfect square it is must end with what? Yes, you are correct. It must end with either 4 or 6. So, we should check this only for 2 digits, that is for 4 as well as 6. So, let us check what we will get when we put 4 in that box, or what we get if we get 6 in that box. So, first let us check with 4. So, let us put 4, it becomes 44. As we have introduced 4 in the units place, we have to multiply that 44 with the same digit. 44 4s are 176. So, we got 176 which is required, then there is no need to check the next one, automatically that option is cancelled. So, just write that 4 here, the same 4 here also, multiply 44 with 4 to get 176, subtract this 176 from 176, we will get 0, and this process is continued till we get the 0. Here we got 0, and the number which is written in the place of quotient is the square root of the given perfect square number. So, square root of 476 is 24. Since this is a new method of division, we get practice, we get acquainted with it with more and more practice. So, let us have one more example of finding the square root by long division method. So, consider the perfect square number 2304. Here we, as we can see, it can be grouped into two groups, one is 04 and one is 23. So, we will consider the first group, that is 1000th place digit and 100th place digit, which is 23, and you can know that 23 is between the two perfect square numbers, that is 16 and 25. Among 16 and 25, 16 is the smaller one, and we will consider that 16, and we know that 16 is the square of 4. So, we will take 4 into 4, that is 16, subtract 16 from 23 to get 7, and write the next group, that is 04. Now, we get 704 as the remainder. As we did in the previous class, 4 is added to 4 to get 8, and as already we have practiced, we have to write a digit in that box units place after 8, and the same digit we have to write after 4 also in the quotient place, and we have to multiply that number by the same digit. So, again this number is ending with 4, again there are two possibilities, it should be either 2 or 8. So, let us check both the cases. So, first we will put 2 and multiply with 2. So, when 82 is multiplied with 2, we get 164, which is too small to 704. Let us go for the next option, that is 8 into 8. So, 88 into 8 will give us 704. So, this is the option which we are looking for. So, now put 8, multiply with 8, 88 into 8 is 704, subtract 704 from 704 and get 0. So, the quotient, which is 48, is nothing but the square root of 2304. Students, as we discussed, here we are finding the square root of perfect square only, but this method can also be extended to non-perfect square only, but for this session is concerned, we will discuss about only perfect squares. Now, we will take one more example, but this time we will take the example of a decimal number, which is the product of two equal decimals. So, find the square root of 34.81 by again long division method. Why I am discussing this one? Because it is quite similar to the one which we did already, but here grouping is different. Grouping is done from decimal point to the right side and to the left side. That means, unit digit and tens digit one group and 0.81 is another group. So, again we have to consider the first group, that is 34, and you know that 34 is lying between the two perfect square, that is 25 and 36, and among these 25 and 36 we consider the smaller one, that is 25. So, we multiply 5 with 5 to get the 25 and subtract that 25 from 34 to get 9. Now, here one more important thing, before we write the next group after 9, there is a point. So, that point we should keep in the quotient, then only we can write the next group, that is 81. So, please keep this in your mind when you are finding the square root of a decimal number which is a square of another decimal number. So, now we got 981, as usual we add 5 to 5, we get 10, and we have units place here to be filled by a digit which is to be again multiplied by the same digit. So, let us find there are two possibilities. When a perfect square number ends with 1, its number whose perfect square it is will end with either 1 or 9. So, we will check both the possibilities of putting 1 and 9. So, first we will check with 1. If we get that 981, then no need to check for the second option. So, first 101 into 1 will give us 101, which is too small. So, the second option is 109 into 9, which gives us 981. So, this first option gone. Now, you can see 981 we can get by putting 9 in the units place and multiplying that 109 by 9 to get 981. Subtract 981 from 981 to get 0. So, we can say that square root of 34.81 is nothing but 5.9. So, in this way we can find the square roots of perfect square numbers by 3 different methods. So, let us have assignment for the today's discussion. The first assignment is define a Pythagorean triplet, find the square root of 81 by repeated subtraction method, find the square root of 324 by prime factorization method, and find the square root of 1681 and 10.24 by long division method. With this, we complete our unit 5 in 2 sessions, and I am Shashikant Joshi, TGT, Government Model Primary School, Aurades, Taluka and District, Bidar. I will be thankful to Swami HR, Assistant Teacher, Government Girls High School, Devanhalli, Bengaluru Rural District. Thank you.